Okay, so here we're going to look at the concept of STP. STP. So STP stands for standard temperature and pressure. STP stands for standard temperature and pressure. So the standard value for temperature is 0 degrees Celsius, and that is equivalent to 273 Kelvin. So standard temperature is what? 273 Kelvin or 0 degrees Celsius. Then standard pressure is 1 atmosphere, right? ATM means atmospheric pressure. ATM. ATM means what? Atmosphere, right? So pressure, the standard value for standard pressure is what? The value or this value for standard pressure is 1 ATM, 1 atmospheric pressure. And that is also equal to 760 millimeters of mercury, and that is equal to 101,325 Pascal. So these are the values for standard pressure. Standard pressure is equal to 1 atm or 760 millimeters of mercury or 101,325 Pascal. Your PA is your Pascal. Pascal. So, and this is the value for standard temperature, 0 degrees Celsius or 273 Kelvin. So let's look at this question. At standard temperature and pressure, at STP, a certain mass of gas occupies a volume of 800 centimeter cube. Find the temperature at which the gas occupies 740 centimeter cube and has a pressure of 675 millimeters of mercury, right? So the first thing I would want to do is to bring out the parameters in these questions, right? So the question is at STP, at standard temperature and pressure, a certain mass of gas occupies a volume of 800 centimeter cube, right? So at STP, the question says at STP, which is at standard temperature and pressure, the volume of the gas, which is V1, is equal to what? 800 centimeter cube. So at STP, at standard temperature and pressure, the volume V1 is equal to 800 centimeter cube. So our standard temperature, which will be our T1, will be equal to what? Our standard temperature is what? 273 Kelvin. And I mentioned that before, that standard temperature is equal to 273 Kelvin, right? Then our standard pressure, which will be our P1, will be equal to 760 millimeters of mercury. And I mentioned that also before, that standard pressure is 1 atm or 760 millimeters of mercury or 101,325 Pascal, right? Then find the temperature at which the gas occupies 940 centimeter cube and has a pressure of 675 millimeters of mercury. So find the temperature. So what we're looking for is temperature. So our T2 is unknown, right? At which the gas occupies 940 centimeter cube. So our V2 is equal to what? 940 centimeter cube and has a pressure of 675 millimeters of mercury. So our P2 is what? 675 millimeters of what? Of mercury. So since we have volume, we have temperature, we have pressure, it is the general gas equation that, or the combined gas equation that describes this, right? So we'll apply the general gas equation. So from general gas equation or general gas law, we have that P1 V1 over T1 is equal to P2 V2 over what? T2. This is the general gas equation, right? So my P1 is what? Is 760 millimeters of mercury. So this will be 760 times my V1 is 800. 800 over my T1 is what? 273 Kelvin. 273 equal to my P2 is 675 millimeters of mercury. So 675 times my V2 is what 940 centimeter cube, 940 over my T2 is what I'm looking for, is unknown, right? So I'll represent that as T2. So the next thing I would do is to multiply. 760 times 800 will give us 600 and what, 8,000 over, when you multiply this, you get this, over 273 equal to 675 times 940 will give us 634,500, right, over T2. So the next thing I will do here is to cross multiply, right? This will multiply T2 and this will multiply this. So I would have 608,000 T2 is equal to 608,000 times T2 will give me 608,000 T2 is equal to 634,500 times 273. So the next thing I will do is to divide both sides of the equation by the coefficient of T2, which is 608,000, right? So my T2 will be equal to 634,500 times 273 divided by 608,000, right? So I will use this 608,000 to divide this. That's what I did here. Then the next thing is just to punch your calculator and get your answer, right? So if I bring out my calculator, right, I have 634,500 times 273 equal to divided by 608,000. That will be equal to 284.89. So my T2 is equal to 284.89. And this is what, approximately 285 Kelvin, right? So my T2 is equal to 285 Kelvin. This is my answer to this question, right? So the major thing here is just to be able to fix out your parameters and also to apply the general gas equation here. You must always remember this equation. P1 V1 over T1 is equal to P2 V2 over T2.